time is running out. Okay, so let me get my notes here. All right, so we're gonna do some fun problems here. All right, number one, I'm on my chapter 9 notes. How many ways can you arrange 5 books on a shelf? Anybody have an idea about that? 5 ways, that's a guess. It's a little more than that.
Isn't it like 25 or something?
Well, it's even more than that. Let's think about this for a second. Let's suppose that I have a stack of 5 books sitting here on the table, and I'm going to arrange them on a shelf, okay? So here's my shelf, okay, 5 slots. So I'm going to reach down and randomly grab a book. How many choices do I have to put in that very first spot? 5 choices. So this is not 5 books. This is 5 choices for that spot, right? So I grab one, I put it down. Now, how many choices do I have for this spot?
4.
4. And then 3, 2, and 1. And these are all multiplied together. So it's 5 times 4 times 3 times 2 times 1. So you certainly could do that on your calculator. That's 120. So there's 120 ways that I can do that. What if there were, I don't know, 12 books? What would that look like if I were going to arrange 12 books on a shelf? 12, 11, 10, and so on, right? Now, again, you got a calculator, so you can absolutely type that in. But the bigger the number gets, the more tedious it becomes, right? Even 5 times 4 times 2 times 2 times 1 wasn't so much fun. So, you paid a fortune for this calculator. It's going to help you out. So, if you go, your calculator out, if you go to your math, your regular math button right here, the menu across the top, there's different menus. The last one is probability. Probability. So click over to probability. The fourth, for me it's the 4th, the exclamation point. That exclamation point is the symbol for factorial. This is 5 factorial. Instead of writing out 5 times 4 times 3 times 2 times 1, we put 5 exclamation point. That is the factorial symbol. And that's how we write it, and that's the button we press. So if you go back, there's regular, just press 5. Nope. Get out of that menu. Second quick, press 5, and then math, prob, down to the exclamation point. It should say 120. So you press the 5 first, and then you go over to math prob, down to exclamation point, and that's 5 factorial. So if you have a big one, like if you have 50 books on the shelf, you could do 50 factorial. You wouldn't have to type in all the individual numbers. Okay? All right, so we know how to use that button on our calculator, and we know what it means. Number 2, how many ways can 9 people stand in a line? I want you to think about that for a second. Fundamentally, is that the same problem as 5 books on a shelf?
Yes.
Isn't 9 people in a line the same as 5 people in a line, or 5 books in a line? So what is the answer to number 2 going to be?
362,000.
It's 9 factorial, right? Which you said is what, 362,000?
880.
880. Is that okay with everybody? See the similarity between the 2 problems? How many ways can prizes be awarded for 1st, 2nd, and 3rd place in a race with 10 contestants? All right, now, think about that for a second. You got 10 people, they're gonna do a race. And you're gonna give away a first, second, and third place prize. Not everybody's gonna get a prize, right? Okay. How many choices are there to finish first? 10. There's 10 guys running the race, right? So there's 10 guys that could finish first. Somebody will. So how many guys are gonna finish second? 9. And third? 8. And it's how many choices of guys, not how many guys actually do it. So don't go all the way down because you're not arranging all 10 people. You're only arranging 3, right, 3 spots. So that's why it's just 10 times 9 times 8. So that is 720. All right, Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? Okay, so every day I come to school, I go to the closet, and I grab a jumper, and I grab a shirt. I grab a jumper, and I grab a shirt. How many choices do I have for jumpers? 8. How many choices do I have for shirts? 10. How many outfits do I have altogether? 80. When you pick jumpers and shirts, when you have somebody finishing first and second and third, we multiply. We multiply those choices. When it's an and, if you're doing both things at the same time, I'm wearing a shirt and a jumper, that's a multiply, okay? That's a multiply anytime. So I'm arranging book and book and book and book, that's times. Mr. Ford has 5 sport coats, 12 shirts, and 10 pair of pants. How many outfits does he have? So he gets up, goes to the closet, and he has to pick 3 things. How many choices of sport coats does he have? 5. And how many choices of shirts?
12.
And how many pants? 10. There you go. So how many outfits does he have?
600.
Yep.
Pardon this interruption. Please excuse all choir members to head to the rack for Mass. Please excuse all choir members to head to the rack for Mass. Thank you.
Got frosting on my hand, just realized. Okay. Next. How many ways can the home row of the keyboard, that's like when you sit down at the keyboard, that's where your hands are, and those are the keys on it. How many ways can we arrange those? So let's say they popped off. How many ways could you put them back on there? Well, how many are there? 9. Aren't we arranging them in a row? How many ways can we arrange 9 things in a row? Just like 9 people, 9 books. How many ways can we arrange 9 things in a row? 9 factorial, that's exactly right, the same number right here. When you are arranging things in a row, if there are n of those things, 5, 10, 20, you can arrange them in factorial ways. So if there's 5 of them, it's 5 factorial. If there's 10 of them, it's 10 factorial. That's when you're arranging things in a row. Okay? Big ideas. Big ideas. How many ways can you answer 10 true-false questions? Okay, we're not arranging these questions, we're just answering them. Anybody have an idea? 20, good guess. Not big enough, but that's a good guess. I understand that guess. 100. 100? All right, let's think about it. Here's question number 1. How many choices do you have for question number 1?
2.
2. All right, so then you move on to question number 2. How many choices do you have for it?
2.
2. Question 3. Okay, wait a second. Oh. Question 3 has 2 choices. Don't all my questions have 2 choices? How many questions are there? 10. Am I answering question 1 and question 2 and question 3? Yes? So what am I gonna do? How am I gonna get my answer? 2 to the 10th power, that's right. 2 times 2 times 2, 10 times. Every question has 2 choices. You're answering all the questions, so you're multiplying 2 choices 10 times. I don't know, what is that? 1,024. What if this quiz, instead of being multiple choice, what if it was, or instead of being true false, what if it was multiple choice? And every question had A, B, C, D as an option. How many ways could you answer that?
4.
4 to the 10th, because all of them would have 4 options, right? How many ways can 4 different prizes be given out if there are 10 people in the contest? Think about that. Write something down. What do you think? Or type something in.
Would be 5,040.
Just a minute, let me see. It would be. Alec, how did you do that?
10, 10, 9, 10, 8, 10, 7.
So Alex says, I gotta give a prize to somebody. There's 10 people in the room or in the contest. So aren't there 10 choices for me to give away? I don't know, my marker too. Now, somebody else is gonna get an eraser. How many choices do I have now? I've already given away my markers, so now I only have 9, and then 8, and then 7. And I stopped there because that's all the prizes I have. I'm giving away 4 prizes. Okay? How many ways can 5 people be seated in a circle? All right, let's back up. How many ways can 5 people be seated in a row? 5 factorial. 5 factorial. Let me say this again. N things in a row is n factorial. So whether it's people or books, it doesn't matter. If you're putting something in a row, it's n factorial. All right? Now, when you put them in a circle, it's 1 less factorial. So since there are 5 people, when I seat them in a circle, it would be 4 factorial. Now let me try to explain that to you. When I put people in a row, let me just call them A, B, C, D. That would be one way to arrange them. Would that be another way to arrange them? Yeah. And there's just lots and lots of ways to do it. I'm not gonna write them out. There's 120 of them. So I'm no way gonna write them all out, but there are some, okay? Now, let me take these guys right here, these people, and let me seat them instead of a row. Let me just take that row of people and put them in a circle. Okay? So I want you to think about wrapping these around in a circle. And then I want you to wrap these around in a circle and these around in a circle and tell me about those circles. You don't notice anything about them?
The letters diagonals. The letters are diagonals.
So let's say I take take these people and I sit them down at a circular table, all right? I'm gonna seat these guys at a circular table. So here's A, B, C, D. Look where B is sitting. Isn't B sitting between A and C? Where's B sitting here? Where's B sitting here? Are these different arrangements? Not when you put them in a circle, because circles have the ability to rotate. Lines do not. Where is B sitting? Between A and C? Where's B sitting here? He's at the end of the line. Where's B sitting here? He's at the end of the line. B is in different spots in a row, but in a circle, he can rotate around and still be in the same spot. That's why there are less arrangements in a circle. So, one more time. N people in a row, n factorial. N people in a circle, n minus 1 factorial. All right, 8C. How many ways can 8 books be arranged on a circular shelf? 8 books on a circular shelf. How many ways?
40,320.
What is that? How did you get that, Finn?
8 factorial.
Um,
No.
5,000.
Yeah.
What would it be?
5,040.
Why?
7
7 factorial. It's 8 people, or 8 was people. 8 people in a circle, or books. 8 books in a circle is 7 factorial. 8 books in a row is 8 factorial. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? Okay.
Brother and incest.
So let's think about that for a second. How many license plates are possible if they must consist of 2 letters? What is that? If they must consist of 2 letters followed by 3 non-zero digits. All right, so it has to have a letter and a letter, and then 3 digits that can't be 0.
Is the first one 24?
Help him out.
26.
Yeah, there's 26. Hey, it's okay, you're German,
Yeah.
right? I mean, don't you have a different do you have a different alphabet?
No.
No, you, oh, then you should go to 26. Yeah. So 26, all right, so there are 26 letters to pick from. 26 letters to pick from. How many choices do I have for my second blank? How many? Be careful.
Can you have the same letter again?
Have you seen a license plate with 2 letters the same?
Probably somewhere.
Yeah, I think there are a lot of license plates that have the same, so, yep, we got 26 choices for that one too. Now, what about digits, that's numbers, that can't be 0, so you can't use 0. So how many choices do we have? 9, and 9, and 9. And all those are getting multiplied, guys. What's the key? I'm picking a letter, and a letter, and a number, and a number, and a number. And I multiply all that together, and I'll get some big thing. 492,804.
Pardon this interruption. At this time, could the liturgy committee please head down to the Welch Activity Center, please? The liturgy committee head down to the Welch Activity Center.
All right, now, how many plates are possible if no letter or number can repeat? Adriel?
What do you do 26 times 25 times 9 times 8 times 7?
I think he's right. What do you think?
Yes.
So multiply all that together and that will be the answer to that one. Do you guys listen to the radio? Probably not. Do you ever watch like regular TV?
Yeah, so
Okay, so like channel 13 is WTHR. That's called its call sign. Okay, so how many 4-letter call signs are possible? So like WTHR, that's one possibility. How many call signs are possible if every letter is allowed? If every letter is allowed, how many call signs are possible?
456,000.
How'd you get that?
26 to the fourth power.
Exactly, 26, 26, 26, 26. Everything's allowed, we're allowed to use whatever letters we want. That would be 26 to the 4th power, or 26 times itself 4 times. Now, what if you can't repeat a letter? This is number 12. What if we can't repeat a letter? What would that one look like? 26, 25, 24, 23. Number 13, no vowels.
20 times 21.
So we're allowed to have any letters we want, but we can't use vowels. Okay, so what'd you say?
21.
How did you get 21, Adriel?
I subtracted 5, A,
A, E,
E, I, O, U.
I, O, U are the standard vowels. We're not gonna quibble about all the weird things, but A, E, I, O, U. So 21, 21, 21, 21. Anything goes except vowels. And then 14 says, how many if we have no vowels and no repeats? No vowels and no repeats.
21, 20, 19, 18.
Beautiful, all times together, because we're picking letter and letter and letter and letter, so they're all multiplied together. So, problems 11 to 14, all are the same situation. Does everybody see the difference between them? All right, now read carefully. All right, 15. How many how many batting orders are possible if a baseball team has 9 starters? How many batting orders are possible? So here, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my batting order. So I'm the coach, I sit down, I gotta fill this out. How many different ways can I fill this out? How many choices do I have to bat first? 9, and then 8. Wouldn't this just be 9 factorial? Because when I do a batting order, aren't I really just lining them up? And how many ways can I line up 9 players? 9 factorial ways. What if the pitcher has to go last though? How many ways, I still have a batting order, but the pitcher has to go last. Now that means that this spot right here has 1 choice, that's the pitcher. So how many guys are left to actually line up? I'm not lining him up, I'm saying you are here.
8.
I now have 8 to line up, so I now have 8 choices, and then 7, 6, 5, 4, 3, 2, 1. That's 8 factorial, because when I told you the pitcher had to go last, I took him out of the mix, and now how many people do I have left? 8. I gotta line up 8 people in a row, so that amounts to 8 factorial. I am not taking time to type all these in, you guys can do that. I'm just setting them up, you know how to type all that in. No, now the pitcher has to go last and the best hitter has to go third. So the pitcher has to be here and the best guy has to be here. So there's only 1 choice. for these spots. Okay, so here's my batting order. I'm the coach, I'm lining my boys up here. And I put this guy here, and I put this guy here. How many guys are left to actually line up then? 7. How many ways can I line up 7 people? 7 factorial. 7, 6, 5, 4, 3, 2, 1. 7 factorial. All right. 18. How many 1-digit, 2-digit, or 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5, 6? So I have 1-digit numbers, I have 2-digit numbers, 1 or 2 or 3-digit numbers. So I'm making numbers, but I'm only allowed to use the digits 1 through 6. Okay, well, how many choices do I have here then? 6. I mean, this, if I'm making a 1-digit number, it's either gonna be a 1, a 2, a 3, a 4, a 5, or a 6, right? So I have 6 choices for 1-digit numbers. Now, what about 2-digit numbers? Well, how many choices do I have for my first digit? 6. How many choices do I have for my second digit? Don't overthink it. 6. Couldn't I have a number like 22? So I'm picking a first and a second, so that would be 36 of those. And there's 6 of these. Now what about 3-digit numbers? 6 times 6 times 6. So this is numbers like 137, or no, not 100, 134, or 222. All those are 3-digit numbers containing the digits 1 through 6. And that's 216. Now, for the first time today, we've got this situation. We are going to make either a 1-digit number, or a 2-digit number, or a 3-digit number. Or means add. If there are 2 ways to do something, and 3 ways to do something else, and I have to do one or the other, I'm going to add them. If I'm doing them both together, if it's an and, I multiply. So number and number, 2-digit, number and number, that gets multiplied. But 1 or 2 or 3, that gets added. So I don't know what that is altogether. 258. Okay, so this is big, because we're gonna be doing lots of this kind of stuff with our probabilities. If we're doing them together, if it's X and Y, I multiply. If it's X or Y, I add. Okay? Alright, what's next? How many 5-letter words can be formed from the letters of the word Chevy? So imagine you can take this piece of paper, cut it up, you got these 5 letters, C-H-E-V-Y, and you are going to arrange them in different ways. Well, how many ways can you do that? You're gonna make a word, we use that word loosely, not a real word, a letter combination out of those 5 letters. So how many choices do we have for this first one? 5. And then 4. And then
3, 2, 1,
and we're gonna multiply all those together.
120.
That's it, 120. Right, now stop. Guys, you knew that. How many letters are there? 5. What are we doing with them? Arranging them in a row, a line. How many ways can we arrange 5 things in a line? 5 factorial, right? Okay. How about how many 6-letter words can be formed from the letters of the word Precal? 6 factorial. 6 letters, Precal. Now I'm gonna skip down to 23 because it is similar but a little bit different. What is different about this word? Well, what does it have that none of the, Chevy and Precal did not have this? What phenomenon does this word have?
Words that repeat.
Letters that repeat. Letters that repeat. Now, how many letters are in that word total? I mean, altogether, pre-calculus says how many letters? 11. So we're gonna start with 11 factorial. Now, remember when we did Chevy, we started with 5 factorial. When we did pre-cal, we did 6 factorial. Always start with however many you got factorial, so it's 11 factorial. Now, as Adriel noticed, there are 2 C's in the word. So we're gonna take that 11 factorial and we're going to divide it by 2 factorial because there's 2 C's. But wait, there's 2 L's, right? So I'm gonna divide by another 2 factorial. So this is the C's, this is the L's. I do each letter separately, okay? So there's 2 C's, 2 factorial. There's 2 L's, 2 factorial. And there are 2 U's, so another 2 factorial. Now, 2 factorial, 2 factorial, 2 factorial. Do not try to simplify that. Don't try to make that 6 factorial, 8 factorial, 8. You can't do it. Don't do it. When you type it into your calculator, be very careful. Since you want to divide by all of these things, you've got to put that in parentheses. So 11 factorial, so 11 math over to prob factorial, divided by parentheses 2 factorial, 2 factorial, 2 factorial. And tell me what you get. You should have gotten, let me get the common right, it's about 4,989,600.
Yep.
All right, quickly look at 24. How many 11-letter words can be formed from Mississippi? What are you doing right now? I hope you're counting up the letters. How many are there? Yoo-hoo, Mississippi has how many words? How many letters? I mean, 11. So we're gonna start with 11 again. 11 factorial, because there's 11 letters. Now, what do we got this time in terms of duplicates? 4 S's, so divide by 4 factorial, that takes care of the S's.
4 eyes.
1, 2, 3, 4 I's, that takes care of the I's. It's another 4 factorial, don't forget the factorial. 2 P's, a 2 factorial. Now we're gonna type that in. Anytime you divide by more than one thing, please make sure that you have it in parentheses. I got a lot smaller than 34,650. Double check that for me, I think I did it right. All right, we gotta get 21 and 22 down here before we go to church. So here we go, 21. How how many social security numbers are possible if anything goes? So I don't really think there's somebody out there with all zeros, but anything goes, we're gonna count everything. So you know what a social security number looks like, right? It's got 3 digits, and then 2, and then 4. And if anything goes, any digit goes anywhere, then how many options would there be for each of these blanks?
10.
10? Aren't there 10 digits? Now, we used 9 before because we couldn't use 0, but aren't there 10 digits? So this is 10, 10, 10, 10, 10. And what are you gonna do with all those numbers there? You're going to multiply. So basically, it's 10 to the
9.
9th. Assuming everything goes, that's all the social security numbers there can be. That's it. That's interesting. All right, how many telephone numbers are possible in the 317 area code? So we have 317, then, right? These aren't being multiplied, that's just the area code. So assuming that any number can go anywhere, even zeros and everything else, how many phone numbers are there? What would all these blanks be? 10. Wouldn't that be 10 to the 7th?
Yes.
Hey guys, I want you to think about that for a minute. 10 to the 7th is what number? What is that?
1 was 0. So 7 zeros.
So it'd be 10 million?
Yeah.
When I was growing up, I have 5 siblings. So my family was a family of 8. We had 1 phone, right? You had a house phone, that's what you had. Now that family of 8 has how many phones? At least 8, right? They keep running out of phone numbers, so what do they keep doing? Anybody know? They keep adding new area codes, because every area code you create adds another 10 million phone numbers.